Hi, seventh grade. We are already past the halfway point in review. Today's lesson is on similarity. So we're going to look at how to identify similar figures or like classify them and then apply similar attributes. So first, proportional sides and equal angles. So we're looking at two similar figures and their sides are going to be proportional and their angles are equal. And it actually tells us that they are similar. So let's go ahead and take a look at what that means. So first we have corresponding, which means the same thing as matching. Sides are proportional. Meaning the same ratio. They grow and shrink at the exact same rate. Like they have to get bigger or smaller at the same time. Like boop, boop, all of the different matching sides. So when we have two similar shapes and they're not facing the same way, I'm gonna actually put my little shape I've cut out here, the small one. We want to orient them or move them around so they're facing the same direction. So right now this one is upside down. So we're actually going to draw it so it is facing the same way as the big shape. So I'm already cut this out, so I'm going to trace mine, but you can just freehand draw. And it's kind of hard sometimes to see where all of the different spots change to, but you can always, even on Star, like move your paper around and kind of really think about where everything should actually go to match up. So like this W is actually going to be up here. So see the little pointy part? And then if I'm going down the W to the bottom, we have the Z. And then across from the Z is the Y. And then right here is the X. This part is really important. When you did a similar problem in your part-to-part proportion quiz, a lot of us accidentally got 12 instead of 18 because we didn't rotate the shape quite right. Now that we have things matching up, we can even, you can just look at this visually, but I'm actually going to draw, kind of color code my matching sides. So my corresponding sides, the things that would match. So looking at these colors, this side is going to correspond with this side. This matches with this matches with that matches with that. So that's going to help us write our ratios. And I'm even going to say that this is my big shape and here's my small one. So we're going to go big to small. You can go small to big, it just needs to be the same comparison twice. So for my big one, let's start with the orange line. We have K to L, so I'm going to say line KL matches with WX on the small one. Then LM matches with XY. NM matches with ZY, and KW, or wait, KN matches with WZ. So those are all of the corresponding or matching sides. So all of these sides shrunk at the exact same rate, the same ratio. The other thing about similar figures is that corresponding or matching angles are equal. So if I even take a look, here's my little cutout of the shape. If I match up, so here's angle W that corresponds with angle K, we can see that angle K, this is my big shape, is the exact same measurement or just as big as my angle W, which is my small shape. So even though this guy got shrunk he's smaller, the angles are actually exactly the same. And that's going to be for all of the angles. So angle L is going to be equal to angle X. Angle N is equal to angle Z. And then last but not least, angle M on the big shape, so big to small, is going to be exactly the same size as angle Y. So that's kind of the properties of similar shapes. The sides are proportional, same ratio. The angles are equal. We then apply that to similar figures. So they said that these two, the window and the door, are similar to each other. They're proportional sides and equal angles. We can use the proportional sides to make a proportion and find out that missing measurement, the height of the window. I'm going to draw these as two separate shapes. So on the door, the base is 84 and the height is 210. On the window, the base is 60 and the height is unknown. We don't know how tall it is. So here I'm going to even say that this is bigger and this is smaller, or that's the door, that's the window. However you want to just separate out your comparisons. And we're going to go big to small, and we're going to do corresponding sides to set up two equal ratios, to set up a proportion. So the big height of the door is 210. To the small height, we don't know. The big base of the door is 84, and we know that the window is 60. I can now solve this proportion and figure out the height of my window. If you like, you can actually even do a proportion like this, where we actually go big to small. So I'm going to do two equal ratios, but going from big to small horizontal instead of vertical. So I can go 210 for the big as the height. I don't know the small height. 84 for the base of the big one, and 60 for the small. All right, go ahead and pause your video. You can solve this proportion. You can even simplify your ratios before you solve. It's up to you. But pause.